Hello and welcome to UILBytes. This is lesson 4 in our discussion of Boolean identities, and in this one we're going to talk about several more of the laws that we're listing under the UIL list. Specifically the two identity laws, the double negative law, the complement law, and De Morgan's law. So let's take a look at them. The identity law is very similar to how algebra works. Anything times 1 is going to be what you had. Anything plus 0 is going to be what you had. Same thing here. Any term, whether it's true or false, ANDed by 1 remains the same. Any term ORed by 0, by false, remains the same. The double negative law is pretty easy, and the way I used to think about it is think about a double negative as the wings of a bird. They just fly away. So when you see a term that has two knots on top, and the two knots have to span exactly the same amount or the same part of the expression, then they can just disappear. They can fly away. Double negative. So wings fly away for double negative. Here, when you have opposites, true or false, you're going to get 1. If you have with or. Opposites with and always become 0. Those are the two laws of complement for or and and. And then finally, De Morgan's laws. And here we'll talk about the fact that when you knot two terms that have an or connecting them, you break the knot and then you change the or to an and, putting the knot separately into two parts over the two terms. Likewise, over the and, you break the knot, switch the sign to or, and put the two knots separately. So let's take a look at some examples that demonstrate that. So here we have A and 1. Well, anything times 1 and 1 just simply stays A. And here, if you have B and C and D and 1, you just simply have B, C, and D. Nothing changes. Same thing here. A or 0 just remains A. Anything or false is going to be whatever that term was to begin with. It's the identities law. And then here you have B, C, D, or 0, just simply stays B, C, D. Here is the double negative law. Again, the two wings on the bird, they just fly away. So you're left with A. Same thing here. Now notice that the two knots have to be over exactly the same amount on the expression, and they are in this case. So we have A, B, C. Here, this is the law of complement. When you say A or not A, some term or its opposite, that's always going to be 1. It's always going to be true. Because if you think about it, if you have opposites, one of them will be true, the other one false, or vice versa. And anything when you or, if one of the two parts is true, it is simply true. Likewise with and, if you and opposites, one of the two terms, whether it's complex or not, will be false. And therefore your result is false, so it's 0. Now let's take a look quickly at the De Morgan's laws. Here, when you have a knot that spans across an or, you simply break the knot and you write the two terms separately, switch the or to and you get that term. Here, when you break the knot over the and, it's just not and then or. And if you think about the logic, it makes sense. Here you have a three-way knot. You can do the same thing, but you can go ahead and break both knots and be sure and switch the sign, or switch the term, the operator I should say. Here we have three ands that are spanned with a knot. So you have not A or not B or not C or not D. And so here, again, some more very, very powerful laws, especially De Morgan's, in simplifying expressions down to something that's more manageable and easier to deal with. Okay? See you next time.